And sorry. Hey everyone, it's Hacking AI, and my voice is a little bit chirpy, sorry. it's, it's just because it's 5 a.m. in the morning in my time zone. Hoping it's not 5 a.m. in your time zone though. So I'm glad that you have joined. We're going to discuss very interesting things. So I've put up a small content sheet. We'll talk about cursor AI introduction, and then we'll go about a certain data set that I'm using a lot throughout my experiments. It's called ATIS, and it's about airline ticket customer service conversations. Things like where is my flight due, which airports exist in that location, and so forth. But first, let's talk a little bit about AI code assistants. What are they, basically? Well, first of all, the implementation behind them is through an LLM call. Basically, you can use any large language model you want, but the most common ones are the API ones, like big ones like Claude and OpenAI. Uh, there are others, of course. We won't go into that. There's also, of course, the open source ones, Llama, Quen, and there's assortment of options. So an AI code assistant is a large language model that is helping you to achieve your goals as a programmer, as a non-programmer. It has different uh, automation degrees. So there are code assistants that can take a description like, hey, I want to build a Tetris game, and they can autonomously build everything, like the assets and the code, creating the files, etc. So this full automation. There are options to do it. Like I've shown in a stream in Hacking AI a way to do it through Open Hands or Open Devon as it once called. It, it is possible to work with this kind of autonomous assistants. You converse with them and they create actual output. So this is one way. And when we use code assistance in our IDE, in our development environment, whether it's Visual Studio Code or PyCharm or Cursor AI, uh, you have a built-in code assistant that helps you with code completions, basically completing your thoughts into code. And uh, with Cursor AI, there are other options as well. So code assistants can help with code completions, and they are known also as a co-pilot. You know, that's always something cool to say. There are co-pilots that you help you steer your ship. So that's the basic usage of code assistance as a code pilot. But Cursor AI allows you much more than that. And we'll see its UI, its GUI, and there are other options in that IDE. There's also generating. Basically, when you're in the context of some file, you can have a small pop-up and then have some ask or request of that code. So create another function that's similar and yada yada yada. And then there's also ask. And that's pretty cool. You can ask whatever you want based on the code base, you'll get an answer. So those three options are the options of the code AI assistant. What's the relation to data science? Well, first of all, data science is still code. No matter what are you doing, whether you're building models or doing error analysis, unless you're doing it purely in SQL, which I don't recommend at all, you probably have some code lying around, whether it's pre-processing, whether it's training models, all of those things are still mitigated through code. So it's pretty natural to use copilots or any kind of code assistant to basically help you achieve your software data science goals. Whether it's building out some functions, EDAs, and so forth. Like the Copilot way. I want to write software in a faster way using the Copilot. So this is totally achievable with the tools that I've mentioned. But there is something interesting with a different use case that I want to show. You can use Code AI assistants for annotation tasks, which is not something out of the ordinary. Like you can already do annotation tasks with LLMs based on API calls. So I have let's say 20 pictures of animals, and I'm asking the LLM, which also has a visual component, in each picture whether there's a cat or a dog in it. And it returns me this list of predictions. So it's already possible calling APIs with this kind of requests, whether it's object detection on images or any other NLP task like text classification. Given a customer service conversation, what kind of a topic this conversation contains. So what is new? Why am I streaming about this? Because I want to use this kind of utility, like asking LLM to annotate, not through API calls, but through using cursor features like generate and ask, which is pretty powerful because it lets you do it over any CSV that you have without any code, and you can do it as much as you want. And I really feel like it's like next level ability, like opening any CSV you want, doing dynamic error analysis. It really accelerates this whole process. So without further ado, let's jump into Cursor AI. So the team of Cursor AI, they developed their product as an extension for Visual Studio Code. That's why it will look pretty familiar to anyone who's using it. So that's the first. Ooh, thank you, Diego, for following. I don't have alerts in here. Let me add them. Okay. So I was saying that the alerts, Twitch, you're so dynamic. Okay, so Visual Studio Code is the basics of the product of Cursor AI, and I've already opened up the Ask Anything bubble. Okay, so uh, I'll just give you a tour around what did I open. So this project, it's also a library that I deployed to PyPy. So it's a library called Open Intent Classifier. You can classify any text in any label. Um, so I've opened this project. I'll just give you a small tour. This is the README. So Open Intent Classification allows you to define as many labels as you want without fine-tuning the model. That's the promise. Of course, it does it with various accuracy metrics. It won't solve all of your problems, but it can help you iterate faster. And I already have a CSV lying around this project. Let me minimize this thing. Okay. So this CSV contains rows. The most interesting columns are the text. So let's see an example of that. I would like to find a flight from Charlotte to Las Vegas that makes a stop in St. Louis. Great. We can disregard this one. Okay. The name of the label that represents this text, is flight booking request. Again, this data set is called ATIS, and it's about customer service for a flight booking company. So you will get a lot of flight booking requests. So that's the Y, that's the label. And there's also a prediction. And the prediction seems to match flight booking request. Great. It won't always match. Like, this data set was created by running a model that I didn't train, but I did train it on other data, and then I tried it on this data set to see if I can predict with high accuracy in a zero-shot manner, if I can do this in like how accurate the model would be by using this exact project. Okay, so I instantiated a model, and I have a prompt here that runs the prediction, and it's not an LLM, it's a small language model, by the way. It's built on T5, but I won't go into that right now. Our purpose now is to do some kind of a verification on the Y column, sort of an error analysis. When you have errors, there are many kinds of prediction errors, but let's go into two of them. So the one that every data scientist just loves to get is an annotation error, meaning it's not the error of the model, it's the error of the annotator. Yay! It's always fun to see that the model is more accurate than a human. So this is one type of an error. I'll just give a small example. What does it mean? Let's say we have, I'll go with this example exactly. So I would like to find a flight from Charlotte to Las Vegas. Great. and it would be the label would be, I don't know, a cancel subscription. Okay, it's clearly not a cancel subscription, so annotating that as that, like if the label is erroneous, then the model, whatever uh, the model might predict the correct label, which is flight booking request. So the model might be correct and the annotation might be wrong, which is great. We like those kind of instances. So this is an annotation error. That's error type 1. Error type 2, you know what, I'll write it in our streaming summary. Okay, error types, annotation error, yay, and there's model error. Boo. So the model errors are the ones that we actually try to optimize around, meaning we want to have as less as possible of those. We don't want annotation errors as well, uh, but it's pretty easy to fix them. You just relabel, change the label. It's just hard to detect them. The model errors are harder to get by. You need to retrain or you need to change something in the system in order to reduce them. And that's mostly data science work. We analyze, except from of course building the pipeline and all of that and pre-processing. Our job is understanding the errors of the models that we work on. Not all errors are the same. Some are expensive errors, some are not that expensive. So it really depends on the task, on the use case, and so forth. So there are two types of errors so far. There are annotation errors and model errors. Great. How can we use Cursor AI to find annotation errors? So if we know something is an annotation error, then basically we know that we can we won't count that as an error in the model, and we do need to change the label appropriately. So how would one do that? Let's jump into ask. Great. Okay, so I'm already in the context of the CSV. It's very important to be in this context. Like if we do it in any other context, it won't make sense. So please create a new column called LLM Y, or let's call it LLM label. For the first 10 rows, please analyze given the text. You know what, let's start with something else, even a prior. If we just start with in EDA, let's say I don't know anything about the CSV. And print let's start with a small EDA. Okay. No, we don't want to apply it to predictions, so let's copy it over to some. Let's call it EDA.py. Yep, it's working. Great. So we have nice. It's also an absolute count and a percentage. That's nifty. So we have flight booking requests, of course. That's the main one. I know this dataset. I know it by heart at this point. And these are the next most frequent classes. Great. Now let's back to CSV. Okay. Okay. Now, oops. Okay. Given that, please create a new column. Alright, new annotation. Let's see what will happen. I could have just copy pasted it into the web UI. You know, like ChatGPT, and ask him the same thing. It would do the same thing. But I didn't. I'm using Cursor AI on the fly, open CSVs, and doing exactly the same thing. Okay. Let's copy it over to let's call it okay. Great. Okay, so what's interesting is that it's not familiar with the classes, right? It's kind of inventing its own. So flight booking request with stopover. Well, it might be correct, but it's not a class out of the closed set of classes. So we need to improve our prompt. I don't want it to invent classes. Okay. Don't want this context. I want this context. And of course I can write it like in Python, but I'm trying to show how I'm using cursor AI to achieve my goals. Oh wait, it didn't run in Python even. Great. Well, let's say I'm trusting it for now. Does it select sometimes the number and sometimes it doesn't? Weird. Let's put it like that. Dump txt. Let's just remove this thing. Great. Wait, is it another auto-completion? Wow. That was cool. Wait a second. So I just did some editing of text. It figured that I want to like normalize this thing. You see, like it's using cursor and co-pilots and code assistants. It surprises you. Like it improves with time. This was reading my mind right now. I didn't expect it. So yeah, it will get better. Add to chat. Ctrl Shift L. Let's do this. Okay, but my context is not this one. No. Okay. Fine. Let's go to no. Let's go to predictions. What? That's odd. Can't I just paste it? Hmm. Okay. Okay, great. These are the possible classes. Please add a new column. What is the correct value? So the list and the text column. It's 10 rows. Let's see if we got this. After it will get it right, and it will. We will use cursor for creating some EDA code as well. Okay, so let's copy this thing in here. Yes, I have my LM prediction and it is correct. If fair questions. Yep, this one's correct. Okay. Are there differences between LM prediction and label? Nope. Of course I can write code to do it, you know, by checking whether the the rows that these columns are not equal. This one, element prediction, and label. Yeah, so it is working. Okay. Now for the last piece. Let's see, we want to have some sort of error analysis. Let's say a classification report. Let's add the code to it. So let's say I'm on predictions. Is create a classification report by taking account the predictions column and run. Let's see if you can do it dynamically. It does a dynamic classification report. I'm amazed. Like, I am really surprised. Well, what's it, predictions? It's wrong. I don't have 11 samples based on the first 10 rows. Okay. Based on all rows. Let's see how far can we push it. Great, it's doing it. Yep, data science code assistant. What's better than that? 98. It's probably wrong. Okay. That's what's risky using these tools. You trust their output, but I don't. So let's compare it with a real classification report. Write a method that calculates classification. Let's run sklearn classification report. Great. Okay. Let's put some main in here. Great. Great. Okay. Let's shrink this part. Let's close this thing. Okay, that's That's better. Now, show me the output in a nice formatted way. Okay, let's just look at the number of samples, for instance. So, support. No, we already seen there's a discrepancy, okay? This is my last three things. Let's look at my previous chats. Where is it? Predictions with the Y column. Okay. And you see there are overall 931 examples. And here we have 876. So that's a discrepancy. That's a major one. Do we have a way to explain it? Y count, concat. Nope. Just an error. So this is a great example. Yes, you can use code assistance, but something on bulk, such as a classification report, no reason to use LLMs for that. Just write code, ask them to create the code for you. That would be much more accurate. But for cases that you need, that you want to annotate something, that's a valid use case for a data science assistant. Just as we've seen, like re-annotate something based on a CSV, it won't be always correct. Nothing is, but it is a very useful use case. But don't do it in bulk, okay? 10 rows at a time, something like that. That you can put aside and look and see if it makes sense. Okay, great. I think we've covered most of it. I didn't show how to install Cursor. I think you can manage it by yourself. I'm using Ubuntu. If it's working on Ubuntu, it can work on a Mac in a breeze. So I didn't cover installation, but I think it's okay. It's sufficient. Also, I'll just summarize a little bit what have we done. I've shown the Cursor AI interface, its capabilities, its similarities to Visual Studio Code, because it's based on that. I showed how to use the ask feature. By going over different CSVs, we can ask to annotate them, pre-annotate them. It's all done through the interface of Cursor AI. It's it's a very pleasant experience. You don't need to jump to a web API like ChatGPT and copy paste things there, and you also don't need to write code, API code, like API calls. That for each CSV needs to be a little bit different, and that's why I thought to myself that it's a nice experiment. Like if we can use this dynamic approach in any data source that we have, where we can accelerate some processes of automatic annotation, dynamic automatic annotation. Because sometimes we just want to see if there's some discrepancy. We went over the different error types. So there are annotation errors, yay, and there are model errors, boo. And we always hope for annotation errors. Of course, if there are too many of those, maybe something with our annotation process is wrong. Maybe we need to change our annotation guide, for instance. Great. So that was very pleasant. I hope you enjoyed, and see you next time. Bye bye.